All right, everybody, welcome to Earth Science. We're going to continue with topographic maps. Now, I should have already done another video where I showed you a couple and showed you the hills. You should have already looked on maps for like your own setting, your own house, or somewhere you're familiar with here in Pulaski. And now let's throw some rules at you. And it's going to seem like a lot. This could potentially be overwhelming, but with that little bit of buildup you did, maybe you start to see how these maps work. We'll work these and then we'll keep on practicing them. So don't panic if you don't get it all today. We will figure it out. Okay. So cool little infographic here of how this works. Like if you've got a hill and a three-dimensional hill, of course, this is what it would look like on a topographic map. Again, restating what we're doing here, trying to represent Earth's three-dimensional surface on a two-dimensional map. All right. So here's the basic rules, and then you're going to practice them down here on this sheet. A contour line represents an elevation. Therefore, all points in a contour line have the same value. Okay, so if we had a map, and depending on how this unit goes, we'll look at one for the high school. But if we had one for the high school, we went out there in that front lawn, we'd be at a certain elevation. I don't remember off the top of my head, somewhere around 250 feet above sea level. If you walk on that line, you're not going uphill, you're not going downhill. You're always going to be at 250 feet above sea level. Or maybe we look at it here. If you're walking this line, you're always 30, this is in meters, but 30 meters above sea level. Okay. Everywhere on that line is that elevation. Everywhere on that line has the same value. Sound good? All right, contour lines at the same interval between each line. And now this will vary depending on the relief of an area. And what that means is, in simple terms, how hilly is it? You know, what's it like around here? We've got relatively flat with a couple of big rolling hills. Go into the Adirondacks, and it's much different. It's much steeper, much larger hills, mountains, right? So you're going to have different intervals there to be able to represent what you see on a map, or go somewhere where it's just like totally flat, like, you know, middle of Kansas. You'll have to have a different interval there. Now you won't have to figure those out in terms of like, here's a blank map, what would be a good interval? We just have to kind of vaguely be aware of it and then be able to figure out what the contour interval is. That's really the vocab word that maybe I should have put in here a little better for number 2. Contour interval. It's the amount of elevation change between each line. So it's not, a lot of times it's going to be written at the bottom. It was written at the bottom of this map, but I crossed it off so we could figure it out as a question. But it's not always written there. Sometimes you're going to have to figure it out based on the map, and it's pretty easy to do. This map goes 10, 20, 30, 40. So what's the contour interval? Maybe we'll write it over here. All right, CI, so that you don't have to write the whole word, contour interval. Contour interval, in this case, is 10 meters. It's how much does each line go up by. All right. On many maps, the elevation is only listed on every 5th line. It'll also oftentimes be darker. We call these index contours. It's not really on that map. On this map, we do have them. So there's an index contour there, 250, an index contour there, 300, an index contour there, 350. So the deal will be when it's time to do the contour interval is, if I know that line's 250 and I know that line's 300, what is the value of each line in between? You just have to figure it out. Contour lines should never touch. Let's go back to being in the front yard of the school. If I'm 250 feet above sea level, I can't simultaneously be 260 feet above sea level or 240 feet above sea level. I'm at one value. You know, break it down to saying like my height. I'm 5'9". I can't also be 5'10". At the same time. I'm only one height. I'm one value. So anywhere on this map has one elevation. Now, yes, if there's a cliff, and I believe I said that here, it gets tricky near cliffs. If there's a cliff and it's like straight down, that does get a little bit tricky to do on a map. There's some tricks that are there to allow us to get out of that mess. But again, you won't really have to worry about drawing those on cliffs, so don't worry about that. Contour lines never end. Either reach the edge of the map or circle back to themselves. So circles are okay. This 40 it goes around and comes back. This 30, it goes around and comes back. Others, like this 10 right here, go off the edge of the map. And yeah, they come back on, but that's all good. If don't draw this one on yours because it'll be wrong. But if I were to say, here's another contour line and just mysteriously stops there, that would be wrong. That's a no-no. Don't do that right there. Okay. I don't think we're really going to be drawing them this unit. We're going to be drawing ISO lines later in meteorology, so I don't sweat the drawing stuff just yet. Let's like get down just how these things work, and I think you're going to be just fine. When lines are close together, and then number 7 is when lines are far apart. What does this mean? What it would mean, like over here, if there's lines that are close together, you're changing value quickly. So what does that mean if I'm changing value quickly, if the value is elevation? Or if the lines are far apart, like they might be over here, I'm changing value slowly as I move across our surface. So what does that mean? All right, so let's get the vocab in there. When the lines are close together, we say the hill has a high gradient. Now, gradient is a vocab word that's going to come up a lot. We're going to do one whole separate assignment on this that is dealing with calculating gradients. So really today, or for this lesson, let's just get down that a high gradient is equivalent to a steep hill. So lines are close together, you're changing value quickly, it's going to be steep. You're going to have to figure that out on this map, and it's reasonably obvious. Where the lines are close together, that means a steep hill because you have to go down on this map however many feet each contour interval is worth. You'll be going down, 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 down. If they're all close together, you're changing that very quickly. If you did the last video, when you did the last video, not if, we looked at the ski slope versus the hill on the street in front of my house. That ski slope was much steeper. If we looked at a topographic map of that, the lines would be really, really, really close together. Opposite for number 7, the lines are far apart. There's a low gradient. Again, we'll get fancy. This vocab word we'll unpack much more on a future assignment, which means it is like flat or gentle slope, maybe. All right, sound good? 8 ups the ante a little bit. 8's going to get a little bit harder. When contour lines cross streams, they what do I usually say here? They bend. I don't know why I made the mic so small. They bend upstream. I don't know, pointing upstream. Let's do it that way. So here's what I want to do. I'm going to take blue. Join me on this if you would. And let's say we have a stream flowing like this. Could be the Salmon River for all intents and purposes. Then we're going to switch to black and draw what the contour lines would do. So the contour lines here do this little like notch or V like that. Now the reason for this we'll get into, again, all of this is like there's more to unpack on all of it. We'll get into this when we think about erosion. If you want the quick shortcut, the idea would be that if the stream, wasn't here, before the stream was here, that contour line might have gone straight across. But as the stream erodes away material and takes it out, that elevation sneaks its way upstream. Things tend to migrate upstream. Features, waterfalls, little nicks, little mini rapids tend to migrate upstream because as the stream erodes it away, that stuff's gone. It washes downstream, and the feature moves upstream. All right. If you don't have that, that's no worries at all. The thing to remember, and the thing that's going to come up a lot, and I promise there's going to be questions on this, is that these V's, and you can really call them V's, this is a legal regent's answer, that the V's point upstream, guaranteeing questions on it. I promise, I promise, I promise. So the sooner we get this down, the better we're going to be. That does assume that we know what upstream means. And upstream would be if you're standing in the river pointing to like up where the water is coming from, that's upstream. If you turn around and point where the water is going to, that's downstream. If you were sitting in a raft, you're going to flow downstream. If you turn around and see where you came from, that's upstream. And these little V's on a contour map will point upstream. I'm going to pause this and pull up a topo map. Give me one moment. Okay, we're back. So here's one, easy to spot. This is north of the Salmon River Reservoir somewhere. Just looked like good ones here that I found. So if you can see this little magnifying glass, see how this like goes like that? That's a V upstream. Little smaller one there, smaller, whoop, smaller one there, smaller one there, smaller one there. But nonetheless, that's the deal, right? That V's that way, that V's that way. So what I'm saying is that this is like the top of the stream. This is the headwater, and water flows this way, flows this way, flows this way, and down into the swamp. Okay. Again, I can't say much more than I promise, I promise, I promise it'll be there. The V's point upstream. Cool? All right, let's wrap this up. 9 and 10 get a tiny bit more complicated. And again, this is the thing that I think we'll do in the future. Let's not get into the nitty gritty here yet. Hashard, which is a term for those little tiny teeth mark things, represents depressions. So if you've got like a crater in the ground, essentially, think of the top of a volcano and a really like stereotypical cartoon volcano. It's got that like dip. Um, it's a depression in the ground. That's what those little teeth mean. The first Hashard contour line, I'm almost tempted to just skip this today, but we'll throw it in. I think where you should definitely focus more on numbers 1 through 8. So if this 9 and 10 are like too much, don't worry about it. Press pause, move on. But it'll have the same value as the last. So we'll work on that. Like if you're coming uphill, 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 and you start to go back downhill, how do those values work? It's a little bit of a thing to learn. It's not too bad though. But again, let's think 1 through 8. Those are the big ones. All right. So go back through that list again, and then what you're going to do is come down here and using rule number 1, try to answer these questions. Then use rule number 2 to answer this question. Use rule number 3 to answer this question, and so on. And that way you can come back up and say, geez, I don't know this. Come back up and read the rule. Oh, if rule 1 is this, and that's what Mr. F's trying to ask me about on here, what's the deal? Okay. So see if you can answer those. I will post an answers video, but I want you to do that first on your own, and then do the answer separately. Sound good, folks? All right. Thanks for keeping up. Good job.